Hello everyone, welcome to Legacy IAS. So this is our current affairs for this week. Again, there are 5 topics. First one is this. So India's silicon revolution begins in Odisha. What is this? So this is nation's first advanced semiconductor packaging unit. This has been made or started in Odisha. Now, the investment will be about 1944 crores. The capacity will be 70,000 glass panels per year. Now, what we'll be making here is basically glass based 3D chips. You'll understand all these terms. Glass based 3D chips we'll be making, which will be very useful in all these different dimensions: artificial intelligence, 5G, defense tech, all of them. Now, let's start this. So first is, what is 3D glass semiconductor project recently launched? So this is India's first advanced 3D chip packaging unit in Odisha under India's semiconductor mission. Fine. Led by 3D Glass Solutions USA. So this is being made by a company based in USA, and they are basically, this is mainly a packaging unit. So everything is done by them. Here you are doing the packaging. Then focus is on glass substrate panels, advanced chip packaging modules. We'll understand what are all these. Now, before you do this, let's first understand what are 3D and 2D chips. Very important. See, so the traditional system of how they are stacked is like this. So how chips are stacked? So let's say this is a chip. Now different components, different layers of chip are arranged in a 2D pattern, connected like this. Okay, so if this is the chip, it is connected like this. Now it requires a lot of area. Also, it is not as efficient as if it were based on 3D model. So this is 2D chips. This you understand. Most chips that you see around the world are 2D. Now, there is also something that we know as 3D chips. Now, what are these? This we'll understand. So 3D chips are what? They will do vertical integration. That is, there will be layers 1, 2, 3, any number of layers. So instead of the connections being on the same plane, they are perpendicular, or they are stacked like this. This is called the 3D chips. Now, of course, it will have some advantages and some disadvantages, mainly advantages. So let's look at here. So now, let's first see this. Benefits of 3D integrated circuits. So if you see here, what are the benefits? First benefit is you get it more dense, correct? You don't have to occupy a very large area to get the results. Then other thing is, because the connections are made in such a way, the power requirement is much lesser. So this is much more efficient also. Okay, there are details how they are joined which makes them more power efficient, which we won't go into. Then bandwidth also is much better here. Understood? So these are the advantages, but there are challenges also. What are the challenges? See, first thing you understand that the floor planning of this will be very complex, correct? Because which should be joined where, like this one is joined here, this one is also joined to this, correct? So all this floor planning is much more advanced things. Mostly we have developed things planar. Then the second thing is thermal. If you see it, if it was horizontal like this, can you feel that heat dissipation is much easier? Some heat will be generated by different parts, different layers. The heat dissipation is much easier. But if you stack them like this, then can you see that the heat dissipation is stopped by the other layers? So here there are issues with respect to thermal cooling. So there has to be different systems of cooling. So all these are disadvantages. Then now let's come to this, which is what is 3D glass semiconductor project. So what issues you understood here? The issues that you understood here, these are dealt with. This is mainly an issue of silicon semiconductors. So instead of that, if we use glass, then even these issues of thermal, all these are also solved. Okay, so this is why India is focusing on this. Now let's see this. So what does 3D glass chip technology work? So this uses glass substrate instead of silicon. Understood. Enables vertical stacking of chip components, 3D integration. Understood. Then combines multiple functions within a compact structure. Correct. 3D chip. Then what are the advantages of 3D glass semiconductor? So it has more thermal stability. Understood. Because the heat dissipation is much better here. Lower signal loss. Okay. Then higher precision and more computing power in same space. So these are the advantages of what? Of glass substrate when you use instead of the silicon substrate. Now, why is this project strategically important for India? Why it is important? So first thing, this places India at cutting edge semiconductor packaging. This you understand. Entry into advanced chip value chain. Applications are all these are there. Reduces import dependence. Applications are very simple. Correct. Now, next, how does this relate to showing Moore's law? Slowing of Moore's law. Now, Moore's law is nothing but a very simple law that, not really a law, that the founder or the co-founder of Intel gave, that every 2 years the transistors double in their capacity. Now, because over last few years what we have seen that the planar structure that we have for transistors for all these chips is not working that well. So this same has not been achieved, or it is said that it won't be doubling every year from now. Correct. Now, if it is not doubling, then we must have some other way which will make it much more efficient, and that is the 3D chips. So this is now slowing due to physical limits, heat constraints. That is why shift towards 3D packaging and chiplets is needed. Okay, then next, what is ISM and what changes are expected in ISM 2.0? So this is what? This is Indian Semiconductor Mission. India's Semiconductor Mission. Now, it was launched in 2021, 76,000 crores. Correct? Then, goal is full semiconductor ecosystem from fabrication, packaging, design, everything we wanted to do in India. Now, this all we started doing. Okay, small steps we took here in all these fabrication, packaging, design. Actually, design we are doing much better. Okay, now the focus of ISM 2.0, okay, is actually on ancillary industries. What are ancillary industries? So ancillary industries are industries that support this. For example, for making these silicon chips and all, you need very clean gases, you need different kinds of substrate materials. So all those will be held by some other industries. So those are called ancillary industries. We are focusing on developing more ancillary industry. Stronger design push will be given and market linked incentives. This is what ISM 2.0 will be about. Don't get confused. If in exam they say ancillary industry, people think that this should be done now. The initial should be this. Correct. So basically, full semiconductor ecosystem was the first one, but we were still too much dependent on import. So we were able to do fabrication, packaging, design, but mostly it was imported goods. So that's why we need ancillary industry, so that we can really make things on our own. Then next topic is green crackers. Okay, green crackers are different kinds of technologies which can be used to produce sustainable crackers. Okay, now let's look this. Why are firecrackers in news, and what are the major concerns with traditional fireworks? Now, see, fireworks accidents and very high noise levels in Thrissur, Puram have raised safety and environmental concern. Understood? So there is incidents, fire incidents, and also the issue of very high noise level. Correct. Now, because these are the two issues, also they release toxic metals like barium, strontium, and copper, cause respiratory issues and health hazards. Understood? Now, sharp rise in PM 2.5, PM 10 also during festivals. Example, Diwali and Delhi. Okay. Then excessive noise affects infants, elderly, animals. Then high temperature around 1200 degrees Celsius and illegal manufacturing increases fire and explosion risk, because when they burn, they are consisting of very high explosives, so they can reach temperatures like this. That's why if anybody is hit with any of these, they tend to sometimes even die, correct, because this is very high temperatures. So these are issues with the traditional firecrackers. Now next thing, what are safer alternatives to traditional firework? See, there are many different technologies that can be used. First is this: green crackers can reduce emission by 30 to 35% and avoid banned chemicals like barium. So green crackers, similar thing, just made of more sustainable materials. So the emissions are reduced, okay, and less of toxic elements are used here. For example, barium and all is not used here. Some other compounds are used. Then cold spark technology produces visual effects without explosion, smoke or high temperature. Now understand what is this cold spark technology. So what you do, you take metals like zirconium, titanium. Now you take very small or very small particles of it, very small, almost minuscule particle, microparticles of this. Now these metals when heated, they tend to glow. Okay, now what you do, now they don't have to be heated a lot. Even if they are heated for like 60 to 100 degrees Celsius, this is enough. 60 to 100 degrees Celsius is enough. That much will suffice. Now what you can do, they won't produce any noise. This is not explosion. This is just, if you want to do fireworks, you want to see lights, correct? So this can be released in the air, very micro particles, and because they are heated to 60 to 100 degrees Celsius, even if it hits anybody or anything like this, it won't cause that much of an issue. There won't be explosion, so there won't be noise pollution also. It will go up in the sky and then it will look as beautiful as you see, correct, see with fireworks. Then this is called cold spark technology because it is happening at a much colder temperature. Then drone shows create aerial visuals using LEDs without pollution. You might have seen light shows, LED shows using drones, correct? Same effect it can create. Laser and light shows offer visual spectacle without smoke or debris. Then projection mapping creates digital visual on buildings without physical pollution. Like you might have seen projection buildings, like where it is written I love Shanghai or I love New York over buildings, correct? So those are called projection mappings. That also looks beautiful, okay, and vibrant, and it does not need any fireworks. So these are the safer alternatives. This people tend to know. These are some more that you can write if it comes in the exam. Then cold spark technology, I've already explained you how it works. Now, one thing you need to see here is this. So fireworks are regulated under Explosives Act 1884 and Explosive Rules 2008. Now, PESO is the nodal authority responsible for regulating manufacturing, storage and use of explosive. Now, Supreme Court allowed only green crackers and banned barium based series crackers in India. NGT also gave a similar decision for NCT, that is near capital territory, but of course none of it is followed. Noise pollution rules also come into play when the noise being produced is very high. Okay, then what are noise limits, risk and challenges in adopting safer alternatives? So maximum firecracker noise is 125 decimal at 4 meters, while safe ambient levels are only 45 to 55. So you understand that firecracker noise is so much more. That's why if you go near any barat, any kind of wedding, you can almost stop hearing. It is so loud. Okay. Then then so in residential areas, this is the limit, 40 to 15 silent zone. Then high noise affects infant brain development and disturb patients and animals. WHO ranks noise pollution as the third most harmful environmental threat. Correct? Then high cost 400 per unit. Because of high cost of the safer alternatives, import dependence and cultural preference hinder adoption. Then last, weak policy push slows transition towards safer alternatives. So in India, even the Supreme Court has passed decisions, government has done many things, but at the ground, on the ground, implementation is still very poor. You can still get crackers very easily and you can fire them. You should not do much, but yeah. Try this MCQ. Okay, so what it says? It says with reference to green cracker, which of the following statements are correct? These are developed by CSIR NERI. Okay, yes. They completely eliminate particulate matter emissions. What do you think? Completely eliminate? No. Completely eliminated is would be wrong. So this is absolutely wrong. They avoid use of chemicals like barium and lead. Correct? We have seen this. It was written that it avoids barium, which is toxic in nature. Now, so answer becomes 1 and 3. Understood? Simple. Then try this question. This is about Petroleum and Explosive Safety Organization. Now, try it right. Okay, then let's see this. So first, it says this Petroleum and Explosive Safety Organization. Now, some people will get this wrong. So basically, functions under Ministry of Commerce and Industry. This is absolutely correct. Don't get confused by the word petroleum. This is about Petroleum and Explosive Safety Organization. So this is Ministry of Commerce only. This is about firecrackers and all these explosives. Okay, then it regulates manufacture, storage, and use of explosive. Yes. Last, it is responsible for prescribing noise limits for firecrackers. What do you think? No, it is mainly about explosives and their safety. They will not be giving noise limits. This is something that the Ministry of Environment, or which is the Central Board of Central Pollution Control Board, all these will be deciding the noise limits, not this. Okay, so answer becomes 1 and 2. Then now we get to GM mosquitoes. Now there are many ways. See, you understand, I don't want mosquito. Hopefully you also don't want mosquitoes. Correct. Now how do you reduce the population of mosquitoes? So the core thing is that you would want to have genes, you want it to have genes which will stop the spread of plasmodium or something that can cause disease in humans. Correct? So that modification you want, or what you would want, if you remember, malaria is caused by female Anopheles mosquito, correct? So if you want to control malaria, what you can do, if most of them are males, first it will stop the reproduction cycle, so less of them will be produced. And if most of them are males, anyway males are not carriers of malaria, correct? You understood these two things. Now see what they are doing. Mosquitoes are injected with a homing gene using a tiny needle. So this is the initial mosquito. Now the gene locks on to the sequence in the X chromosome. So what happens? This is generally done to the male one. Now where it is? Yeah. Now see what they are doing. So in the male germline cell or sperm cell, what they are doing? They are, so male have X and Y, correct? XY they have in their sperm cells. Now what they are doing? They're purposely damaging the X. They're purposely damaging the X. Now, this is a male mosquito that has been injected with this. Okay, this homing gene. Now, the homing gene is injected in such a way that even it will transfer this to the next generation also. Now, first see now. So this is the mosquito male one, which is which is put which is injected this homing gene. Now it will cross with a normal female. So it will cross with a normal female. Normal female will be what? XX. Now this X is useless. You have made it shredded. So this guy, what is the only possibility? That it releases Y, and from here the child gets an X. XY is what? XY is male. Correct? For female, what you needed? XX. So XX is not even possible. So that's why the next generation will have male. Correct? Now the same thing, the shredded X part continues. So the child that is born is of course male. Then this child will try to infect another normal female. Again the same process. Who will be produced? Male. Then again male, 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 male. See. So eventually what will happen? This favors unaffected sperm bearing Y chromosomes, meaning their offspring become 95% male. Can you see here? Except for this and this, all have become male now. Understood? So this is one mechanism. Then why is GM mosquito slash gene drive in use, and what is malaria context? Okay, so let's see this. So recent nature study shows genetically modified mosquitoes blocking malaria parasites in real world African infections. So this also we talked about, that either you want to change them in such a way that they become very bad carriers of malarial parasites. Correct? Then next it talks about malaria burden is approx 5 lakh deaths annually caused by plasmodium and transmitted by female Anopheles mosquitoes. Traditional methods are not working that effectively. Then rising resistance in mosquitoes and parasites weaken conventional vector control strategies. So vector control strategies are everything that we do. We try to keep our places clean. Okay, we try to do pest control, this that is not working very well. There. What are gene drives and how do they work? Now, gene drives are what? This is CRISPR-Cas9. Gene drives bias inheritance beyond Mendelian 50% probability. Now, this is another mechanism. This you try to understand. Okay, so basically, so this is usually based on CRISPR system. Now, what CRISPR system does is basically this. So let's say this is a father, okay, and this is a mother mosquito. Now, they modify only one part of the gene of the father. Okay, so let's say there are two parts. Okay, so they will enter some kind of modification. So modified gene will be there in the one part. Correct? Every chromosome has two parts, this, that, chromosome pair, all that, you know. And here, of course, this is a normal mother, normal genes in both parts. Now, here what you have, in one part you have the modified gene. Now what will happen when they will cross? When they will cross, what will happen? So basically here, along with this, they also have sometimes some kind of CRISPR system. Now, this CRISPR system does what? So basically they cross, they generate a child. Now, this child, you understand, is from this parent, it can have modified gene, and from this mother, he can have the non-modified gene. So basically this child is fine. Okay, so he will also have modified gene. Now, but there is also probability that that the next generation will not have modified gene. So how do you cover that? So what is done here? The CRISPR system will, so let's say this is two parts of a gene. Now the CRISPR system will cut the part which is unmodified. Now once it is unmodified, from this place, let's say it cuts it. Now this place is left blank. So what your cell will do, or what his cell will do, it will just replicate whatever is in the modified gene part. So this part also becomes the same as this. Then the child becomes a carrier of 100% modified gene. Modified gene will usually be something that does not allow it to grow plasmodium inside it, or have plasmodium inside it, or will produce more males, offsprings, whatever, does not matter. Modification is done. Now the offspring is 100% modified gene. In the next generation also, same thing will be done by the CRISPR system, and it continues. Understood? So self-propagating system reduces need for repeated intervention. Unlike insecticides, rapid trade spread allows engineered characteristics to dominate mosquito population. Then strategies and key breakthroughs: population suppression, double sex gene disruption. This we have seen. Population modification, transmission blocking allows mosquitoes to survive but prevents parasite development. This also we have seen. Then Tanzania's field validation shows effectiveness in real world infections beyond laboratory. Shift in approach from killing mosquitoes to blocking transmission ensures ecological balance. Understood? So basic thing is, see, if we are able to achieve this, this is the best thing. Why? Because transmission will be blocked of the disease, but mosquitoes will still grow. They will still be there. Better than this, where you are making all of them males. Correct? That will disrupt the food chain. Correct? But this won't. This is nice. Correct? And here the mosquitoes will grow normally, but they won't be the carriers. So this is what we want. Then advantage risk. So this is much more targeted intervention, reduces dependence on repeated chemical control. Then ecological risk due to irreversible spread of modified genes in wild populations. This is what we were talking about. What if this is what happens in all the organisms of mosquito, all the varieties of mosquito? Then this can cause problem in the long term. Then resistance evolution risk, where parasites may develop countermeasures, like we have created super weeds. Correct? Where there are some weeds which do not die by anything. Now anything you spray on them, they survive. Why? Because of heavy use of herbicides and all this. Then ethical concerns and integration needed with existing tools. Understood? Then try this MCQ. Gene drives, what do you think? They ensure inheritance of a gene in more than 50% of offspring. What do you think? This is correct? Absolutely correct. Then they rely on CRISPR-Cas9 for genome editing. Yeah, in most cases, but maybe. Then they require repeated human intervention to sustain their effect. Is this correct? No, they don't require human intervention repeatedly. Why? Because they reproduce with the future generations. Correct? We have seen this. These traits are passed on. That's why you're making changes in the genes now. If it requires regular human intervention, it is a chemical method only, that you are killing it like this, then again you are killing it like this, or you are spraying once, spraying twice, spraying thrice. Correct? That is human intervention. That is not needed. Answer becomes 1 and 2 only. Then next we come to the rise of infrared technology. Now see, all this is fine. I will first explain you all three ways in which it can be used. Now let's understand it using examples only. So you have infrared technology. Now let's see using example. What you are using in TV remote. Now what you are using in TV remote is actually using infrared technology for sending signals itself. Signals itself are being transmitted using infrared technology. Okay, so that signal, the signals are already encoded in the TV, and it understands that this is the signal for turning on the TV, turning off the TV. Correct? Increasing the volume, decreasing the volume, it understands all of this. So TV remote is directly sending signals which your TV can understand, already encoded. Then the second one is your automatic taps in the wash basins. In airports, mall, you might have seen that you put your hand below it, then suddenly what happens? It starts giving out water. Otherwise, it is not. Now, how it works? So basically, most of these, for example, if this is a wash basin and here is a tap. Okay, now how it works? Understand this. So basically, the sink, let's say in the sink or sometimes in the tap itself, what they will have? They will have IR sensors. So when you place your hand above it like this, what will happen? Suddenly the IR light that is being emitted. So IR light is constantly being emitted. Now, if you put your hand over it, what will happen? It will get reflected by your hand, or the reflection will change and will reach the sensor back like this. Then the sensor is able to identify that there is something in between. That means water should be turned on. Simple. This is how automatic tap works, where signals are constantly being released. Okay, IR signals are constantly being released, and reflection change actually drives action. For example, turning off the tap, then you move your hand away, then also it changes. Correct? The reflection thing, then it turns off. Correct? Now last is this. This is your automatic lights. Now automatic lights work on this principle, that sometimes you just enter a room, you have not even obstructed anything, you have just entered a room and suddenly the light turns on. Especially in washrooms you might have seen this. Now how it works? So basically what happens, these automatic lights, now we also are a very decent emitters of infrared radiations. Correct? So what they have is actually sensors. So they have infrared sensors. Now these are passive in nature. That means infrared will be released by our body. So here it is released by our body. We are emitting infrared radiation. So if I move inside a room, I will release that infrared radiation. Now the detector can detect that somebody or infrared radiations towards it has increased. That means a human maybe has entered, and it will turn the light on. Understood? So this is based on, it is sending IR signals and receiving it. It has photodiodes and all. So this is a much advanced system. This is sending signals. So just like you use radio waves to send signals, similarly specific signals are being sent in TV remotes. Then there is automatic lights which work on passive IR sensors. That is, our own body is releasing the IR infrared radiation. It is just observing it to do an action. You can write this down. This is the core of infrared technology. Everything else is just chaff that we'll talk about now. Now, why is it in use? Sensor-based devices in use due to increasing use of touchless systems like automatic washing machine doors. You have understood the process. Then, electromagnetic nature of light, where light consists of oscillating electric and magnetic fields and can travel through vacuum. All this is fine. Okay. Then, infrared radiation position lies just below red light in frequency. That is electromagnetic spectrum. Then, what are the components? So, IR LEDs as source emit invisible infrared radiation used in devices like remotes and automatic systems. Seen this. Photodiode as sensor act as light sensitive switches that allow electric current to pass when IR light falls on them. This is fine. Emitter detector system forms the basic architecture. Same thing, just written in more difficult words. You understood all. What is the working mechanism? So normal condition where IR light emitted does not reach the sensor due to absence of reflecting object. Object detection principle, when a hand or object comes near, IR waves get reflected back to the sensor. All that written in difficult words. Same thing. What you have to remember? Wash basin, then TV remote, and then the third thing was automatic lights. Then applications, wide application, automatic door, escalator, hand dryer, all this. Optics, condensed matter, quantum mechanics, all this is fine. Now to this. Infrared radiations. Now, what it says with reference to IR light, first, it lies just below red light in the electromagnetic spectrum. Is this correct? Yes, absolutely correct. Here you have infrared light. More than that in frequencies, visible light. Then you have ultraviolet light. This you understand? How you remember this? So visible, here you have infrared, here you have ultraviolet, correct? So this will be like web Gure. So red will be very close to this, infrared and ultraviolet. So violet will be here. Now just below red, correct? This is correct. This is absolutely correct. Now this was a statement that people would do wrong. It is visible as red light to the human eye. No, because people use TV remote, they start to think like this. That is just red light. Correct? That is just red light being shown to you on the remote. Otherwise, infrared radiations are not visible to you. Okay, even if they make it visible for you for in some show or something, that is another red light that is complementing it. Only visible light is visible to you now. Infrared light is not visible to you. So this is wrong. It is used in remote control and sensor based devices. Is this correct? Yes. Sensor becomes A, 1 and 3. Do this. Photodiodes. Do this. Okay, now what it says, photodiodes. First, they act as light sensitive switches. Yes, correct. This is what we had seen. Then they generate current when infrared radiation falls on them. Yes, this is what photodiodes will do. Next is they emit infrared radiation in automatic devices. What do you think? This is wrong. Why? Because that will be done by IR emitters. Correct. This will not be done by something that we know by the name of photodiodes. Photodiodes is all about being affected by infrared radiations to generate small amount of current that can pass a signal or information. Correct. So this is light sensitive switches. They generate small amount of current when infrared radiation falls on them, but are they emitting light? No, they're just the so basically there are two things, emitters and receivers. So these are like the receivers. So answer becomes 1 and 2. Then last is this is about foot and mouth disease. Now why is foot and mouth disease in use and what is its nature? Now see this. So this World Organization on Animal Husbandry. This is not WHO. This is not a mistake. This is World Organization on Animal Health. They have alerted due to unprecedented international spread of a specific FMD, foot and mouth disease, mainly found in cattle. Okay, now highly contagious viral disease affecting cloven hooded animals like cattle, pigs, sheep, goat, buffalo, deer, all this. Understood? This is a viral disease. Next thing that you have to remember, then this is a particular type of virus which causes severe production losses, rarely fatal in adults. Okay, it is not fatal but leads to production losses. Then major economic impact as it reduces milk yield, same thing, production losses, and acts as a barrier to international livestock trade. Correct? Then next thing is, what are the transmission modes and spread dynamics of FMD? Okay, so this is direct contact transmission through saliva, urine, dung, fluid from blisters between infected and healthy animals. Correct. Viral disease, so very easily spread by all these. Then mechanical vectors, human vehicles, equipment carry virus via clothes, boots, tires, and farm tools. So we are also becoming a carrier to it. Okay, it is not affecting us directly, not a zoonotic disease, but it can spread from our shoes, our clothes, from one animal to another. Then infected products transmission through uncooked meat, milk, all this. Then airborne spread allows virus, so airborne is also possible. Then unregulated animal movement and markets, all these are reasons for its spread. Then what are the key features, serotypes, and control measures of FMD? So clinical signs like fever, vesicles appears on the tongues, lips, okay, all this, high morbidity and productivity loss. Then there are 7 serotypes, all of them are completely different. Vaccine for one serotype won't work for the other. Then carrier state in ruminants where virus persists in throat even after recovery. Then no curative treatment and control relies on vaccination, strict biosecurity and culling policy. There is no proper solution to this. Either you are prevent this by vaccine or there is no curative treatment. You will have to do culling policy. If it spreads like anything, culling means purposefully you are killing animals. Then these are the important animal diseases, zoonotic and non-zoonotic. Please try to remember them. This is rabies, brucellosis, anthrax, all these different diseases are there. Please try to remember them. They are very important from your exam perspective.